Welcome to the explainer. It's easy to look at a kid's math homework and just see a bunch of numbers. But have you ever stopped to wonder what's really being taught? Well, today we're going to tear down a real second grade math test piece by piece and use it as a blueprint to see how we're actually teaching kids to think. So let's just dive right in. The big question we're asking is, what are we really trying to build here? What's the end game for a 7-year-old learning math? Because it's definitely not just about getting the right answer. We're going to use this test from a Thai English program as our guide to uncover some of those deeper lessons. All right, first things first. We got to start with the absolute basics, the foundation. Before a kid can apply math to, the real world, they have to get how numbers themselves actually work, how they click together, and just as importantly, how sometimes they don't. So the test kicks off with something that looks pretty simple, but a question like this isn't really asking for the number 4. It's testing a much, much bigger idea. Can you take a whole number, a whole thing, and break it into equal parts? And that, right there, is the heart of division. Okay, but watch this. The test immediately takes it a step further. This isn't just another random problem. It's actually designed to get a student to see the invisible connection between multiplying and dividing. They're not two different things you have to learn. They're basically mirror images of each other. Two sides of the exact same coin. And then things get a little messy, in a good way. The whole idea of a remainder is a huge leap for a little brain. It's that first moment when a kid learns that, hey, the world isn't always perfect, and numbers don't always fit together neatly. This one little concept plants the seed for everything that comes later. We're talking fractions, decimals, all the complicated, nuanced parts of math. So once those fundamental building blocks are kind of locked in, the blueprint moves on. It starts taking these abstract numbers and plugging them directly into the real world. This is that magic moment where math stops being just symbols on a page and starts becoming a tool that you can actually use. And the curriculum focuses on 3 super practical areas: measurement, time, and money. I mean, think about it. These aren't just random topics. They're probably the 3 main ways that all of us, even as adults, use math every single day without even realizing it. Take a question about reading a book, for example. It's not just about being able to read a clock. No, it's about teaching the idea of duration, the passage of time. And that's a skill you need for everything, right? From figuring out your morning schedule to managing a huge project at work. And it is the exact same idea with measurement. These questions are all about building this internal sense of scale. When a kid learns that a meter is 100 centimeters or a kilogram is 1,000 grams, they're not just memorizing facts for a test. They're literally building a mental map of how the physical world is put together. And of course, money. You gotta have the money problems. This is basically a child's first crash course in personal finance. A single question about buying notebooks forces them to multiply and then subtract, all wrapped up in one real-life task. It's a pretty clever multi-step problem that's just disguised as a trip to the store. Okay, so the next part of this blueprint, it completely shifts gears. We're moving away from adding and subtracting and into a totally different kind of intelligence, spatial reasoning. We're talking about the ability to think about objects and shapes in 3-dimensional space. So the curriculum makes a really big deal about the difference between a flat, 2D shape, like a square, and the 3D objects they can become, like a cube. And this is a really crucial first step. It's about understanding how a flat drawing on a piece of paper relates to a real object you can actually pick up and hold. And this right here really gets to the heart of it. The goal isn't for kids to just memorize fancy words like cylinder or cone. Nope. It's about training their brains to see these geometric patterns everywhere, to recognize the cylinder in a can of soda or see the cone in a birthday party hat. All right, that brings us to our final section, and honestly, it might be the most important one. It's about the biggest challenge of all. And what's so fascinating is that it has almost nothing to do with the numbers themselves. So check this out. There's a note at the end of the source material that just lays it all out. The biggest hurdle for these kids, especially if they're learning in a second language, isn't the math. It's the English. Words like remainder, equal, or total aren't just normal vocabulary. They're technical terms. You have to realize math is its own language. I mean, think about a word problem like this one about the farmer. A student has to know that the word sells means you subtract, and buys more means you add. All of a sudden, this isn't just a math test anymore. It's a reading comprehension test. You have to translate the entire story into a number sentence before you can even think about solving it. And this whole language challenge shows up when you're reading data too. Look at this. Before you can even begin to count how many kids like math or art, you first have to stop and decode the key at the bottom. You have to understand that one star doesn't mean one student. It's a symbol that actually stands for two students. So only after you've translated those star symbols into real numbers, 6 kids for math, 8 for art, only then can you actually start to compare them. It's a whole process you have to follow. You go from a symbol to a number, and then finally to an actual insight. So, at the end of the day, what does this one little test really show us? It shows that second grade math is this incredibly deep and rich foundation. It's a complex system that's teaching pure logic, real-world skills, spatial reasoning, and maybe the biggest thing of all, a brand new language for making sense of the world. And that really leaves us with one last thing to chew on. When you look at a blueprint like this, it makes you wonder, is the real goal to teach kids how to find the right answer, or is it to give them the tools they need to start asking the right questions?